Our lesson this week is about simplifying radicals. So we're going to start with the square root of 20. You could find a perfect square that would divide evenly into 20, but an easy way is to actually do the prime factorization of 20. So we're going to start with 20, and we need to find two numbers that multiply to 20. So the first thing that pops into my head is 2 times 10. Well, 2 is a prime number, but I can keep breaking down 10. I know that 10 is 2 times 5, and then I have all of my primes. So this would equal 2 times 2 times 5, and when I multiply this together, I would get 20. So since I have two 2's, this is really 2 to the second power times 5. Alright, so since I'm taking the square root of 20, I can rewrite the square root of 20 as the square root of 2 squared times the square root of 5, because I know that 2 squared times 5 equals 20. And then I just need to simplify this. Well, I know that the square root of 2 squared is just 2, because whenever you take the square root of a square, you just get what's underneath it. So also think about it as like the square root of 4, because 2 squared is 4, the square root of 4 is 2. And then I would just leave square root of 5 as is, because I cannot break that down anymore unless I get a decimal. And we do not want a decimal answer, we want a simplified radical answer. So then I would type in 2 square roots of 5 and submit. The next example is the square root of 75. So once again, let's do the prime factorization for 75. I need to think about what two numbers would multiply to get 75. Well, I automatically think about 3 and 25. Well, 3 is prime, so I can stop there, but I could keep going with 25. I know that 5 times 5 equals 25. So for my prime factorization, I know that 3 times 5 is 75. Well, let's go ahead and write this in a little bit cleaner format. I know that since I have two 5's, this would be 5 to the second power times 3. So up here, I would rewrite this as the square root of 75 could be broken into the square root of 5 squared times the square root of 3. And then just simplify that one step further. The square root of 5 squared, which is the same thing as the square root of 25, would just be 5. And then I would still leave the square root of 3, because the square root of 3 cannot be broken down or simplified anymore. So my answer would be 5 square roots of 3. Okay, now we need to break down 9 square roots of 45. So this time we have a number being multiplied on the outside of the radical. So let's do the prime factorization of 45. I know that I could multiply 5 times 9 to get 45. 5 is a prime number, but I can go ahead and break down 9 even further. 9 is 3 times 3. And then I would stop there, because 5 times 3 times 3 is 45, and all of those are prime. So let's rewrite it in a nice format. Since I have two 3's, this would be 3 squared, or 3 to the second power, times 5. So whenever I rewrite this as a radical, I can break the square root of 45 into 3 squared times 5. So then whenever I go ahead and simplify this, I still have 9 times the square root of 3 squared is the same thing as the square root of 9, which is 3. So I would multiply 9 times 3 times the square root of 5. Well, 9 times 3 is 27, so my answer would just be 27 square roots of 5. Alright, here's our last problem, 8 times the square root of 294. This is a challenge level problem. So let's start by finding the prime factorization of 294. Well, since 4 is even, I know that this number is going to be at least divisible by 2. So when I divide 294 by 2, I figure out that 2 times 147 equals 294. 2 is prime, so I can stop there. But I need to keep going with the 147. I know that 147 is divisible by 3 because 3 times 49 equals 147. 3 is prime, but I can keep going with 49 because I know 7 times 7 equals 49. So my prime factorization for this would be 7 squared times 3 times 2. So let's go ahead and put that in as the radical. So I can go ahead and simplify that. So 8 squared is 294. 8 would stay out on the outside, but I could break 294 into 7 squared, the square root of 7 squared, times the square root of 3 times the square root of 2, because that's what I got for its prime factorization. Now I just need to simplify this perfect square. The square root of 7 squared is the same thing as the square root of 49, which would just be 7. And then I would have to leave the square root of 3 and the square root of 2 alone. So 8 times 7 is 56. And I could actually just go ahead and multiply 3 times 2 together to get the square root of 6. So my answer would be 56 times the square root of 6. Alright, that is it for the week. Let me know if you have any questions.